Now we're at example 4 from our 0.2 number 2 set of notes. We're asked to graph this rational function. And just looking at the rational function, we can see that the degrees, if we're looking at our horizontal asymptote, we're talking about that right now, if we see the degrees, they are exactly the same. They're both 2. And as a result, this kind of fits scenario 2, where we would then just go ahead and divide those leading coefficients. So because they both don't have a really, number in front of them, they're assumed to be 1. And as a result, for our horizontal asymptote, it just comes out to be then 1 divided by 1, which is just 1. For our vertical asymptote, all you have to do is set this bottom not equal to 0. So when we do that, we have x squared minus 2x plus 1 is not equal to 0. We can go ahead and factor this. It will come out to be x minus 1 times x minus 1 is not equal to 0. And since they are exactly the same, we really only need to do this one time. So we have x minus 1 is not equal to 0. And as a result, we should see a VA at 1. So going ahead and graphing these now, we have 1 as our horizontal asymptote, and then 1 as our vertical asymptote. Now, when we want to determine a crossing, this is where things get a little more interesting. We notice that our horizontal asymptote is 1, and as a result, we can then just say, instead of y, we're going to plug 1 in there. So for crossing, we're going to go ahead and plug in 1 for y is equal to our rational functions. We have x squared plus 5x plus 4 all over our x squared minus 2x plus 1. At this point, we're going to just go ahead then and multiply both sides by our x squared minus 2x plus 1 onto both sides. And the reason why we would do this is on the right, they just end up canceling, leaving us with the top x squared plus 5x plus 4. Whereas on the left, when you distribute this 1 into all of these items, well, 1 times anything is still just itself. So on the left side of our equal sign, we still have that in that x squared minus 2x plus 1. Now, when we want to try and solve for x to see where is that crossing occurring, we can go ahead by subtracting x squared from both sides. When we do that, all the x squared terms are actually canceled and gone, leaving us with still negative 2x plus 1 on the left and 5x plus 4 on the right. I like to generally keep my x's pretty positive, so I'm going to go ahead and add the 2x over. So we would end up with 1 is equal to 7x plus 4, and then subtract this constant of 4 over. So we still have 7x on the right side is equal to negative 3, and then lastly just dividing by 7 to isolate x. So we end up then with negative 3 over 7. So there actually is a crossing occurring at negative 3, 7. Now, to kind of help us out in determining like what our image looks like, we would go ahead and create a table by just plugging values in and seeing what they come out to be. So let's go ahead and do that. If I have an x and a y, if I go ahead and try plugging values in, such as, well, I kind of want to pick ones that are close to my vertical asymptotes. So maybe like 2, 3, and 4. We can go with those. And ones, obviously, that are to the left of that. So like 0 or -1, things like that. And we'll even do like negative, we'll say -2. And these ones represent the ones on the right. These are the left. Now, if we go ahead and plug 2 in, we just end up with 2 squared is 4, plus 5 times 2 is 10, so 4 plus 10 is 14, plus 4 gives us 18 on top. On the bottom, when you plug 2 in, you end up with 4 minus 4, so that's just 0, plus 1 is just 1. So we actually end up with 18 over 1, which is just 18. I'll kind of spare you guys the details. I think that you guys can plug and chug or use the calculator to graph this. When you try throwing in 3, you end up with 7. When you plug in 4, you end up with 4 and 4 over 9. When you plug in 0, you just end up with 4 over 1, which is 4. When you plug in -1, that would end up to be 1 minus 5, so that's 4, plus 4, so that's 8. No, I'm sorry. It's -4 plus 4. That would just be 0 on top. 0 on top. And then on the bottom, -1. Yeah, it should just actually come out to be 0. Yeah. Yep. Because you'd get some real number on the bottom. And then when you plug in -2, you end up with -2 over 9. So that's kind of our table, at least. And we can go ahead and graph that now. For 2, we're not going to graph 18. That's just a little too high. But we can do like 3 and 4. So at 3, we had 7. Which is right here. At 4, we had pretty much 4.5. That's close to 4.5. So, which is right around here. At 0, we said we had 4. 4. At -1, came out to be 0. And then at -2, we said it was -2 ninths. So -2, -2 ninths is right around here, thereabouts. And so when we connect our points, oh, that was bad. When we connect our points, we should, at least on the right side, see something like this. On the left, it's hugging. We can see it crosses through that horizontal asymptote. Now the question is, where is it crossing there? Well, we found that specific x value where we saw the cross, and it is in fact to be about -3/7. So again, my image is a little, shaky just because of the graphing by hand, but we can see that it's in between 0 and -1. And that kind of confirms what we saw algebraically when we found the crossing. Now, the y value, we found the x, the y value for that would just literally be your horizontal asymptote that it crosses at, that specific y value. So that specific cross occurs at -3/7, comma 1, that point where we see that cross. Now, when we talked about horizontal asymptotes and vertical asymptotes, we talked about it should be hugging these asymptotes. Well, believe it or not, it actually does hug this horizontal asymptote. Because what happens if you graph it by calculator, or you can plug in more values into your table. So for example, like if you were to plug in -4, you should end up with a value 0. So there should be a point here. So as you can see, it kind of dips down, but then it actually starts to come back up. And then it will hug that horizontal asymptotes. So for asymptotes, at least the horizontal ones, you can actually cross, and then they do start to hug again like they normally, like you've seen in the past. For the domain and range, you know, I think that you guys at this point should be okay with finding those. So again, that is example 4 from the 0.2 number 2 set of notes.